want to record this. So from here, we're just going to slide across, and you'll see that's the very fancy high school one. And then this is the one that we use for intermediate senior phase and for procurement. So, and you just click download now. And then what it's going to do is ask you when you want to save it. So I normally pick desktop. As you can see, I've saved mine to desktop. So I'm not going to save it now, but you would just press save. And then on your desktop, you'll see you've got your calculator. And you can just click to open it. And voila. So that's the calculator we're going to use today in today's workshop. All right. So let's go back here. So the other thing that's really nice and to play with is the GeoGebra link, which you can do geometry on. In fact, let me just show it to you quickly because that's also, oh, sorry, now you're not seeing anything. So GeoGebra, I just have to find it. Here it is. So GeoGebra is really nice for drawing graphs. It's just going to be very slow today. Am I impatient or is it just slow? There we go. Okay, so you can see, and you can do things like you've got the option on view. So you've got 3D graphics, you've got the graphics that we're currently using now, which is for your graphs. So you can do cubes and shapes with them using GeoGebra. You can do plotting points. So really a lot of very nice things that are available on a calculator. I'm sorry, on GeoGebra. And then, of course, some worksheets. Now, Maths at Sharp is more for high school students, but eClassroom is a wonderful, wonderful resource for primary school. I think their annual fee is 60 Rand. It might have gone up to 80 Rand, I'm not sure. So it's just 80 Rand for the entire year. And that gives you access to not just maths, but to all of the different subjects for primary school. So they have beautiful alphabet and number pictures to color in and that sort of stuff. Math Drills, MathX, and worksheetworks.com are wonderful places to find worksheets if you're looking for a particular topic. I like worksheetworks.com in particular because you can actually customize the worksheet to your specifications. So you can say, I want 1 decimal answers or no decimal answers. I want it in centimeters and meters only. And then, of course, it generates a memo for you at the same time. So it's really a nice place to go for generating homework worksheets and just worksheets that you can use for your students to do extra work from. And then, of course, Math Warehouse is FET mostly, but you can go and check because sometimes they have other content as well. All right, fantastic. There's the other one. So this is the other calculator that I wanted to show you. I'll go back just now in a sec. So this S25 is more appropriate to your grade 4s and 5s because in grade 6, you actually can start using a scientific calculator. So grade 4s and 5s are more comfortable with something smaller like the S25. And what's really nice about the S25 is that it's got a mental maths feature. So I'll show you how that works in a jiffy. But that's its main selling feature, and it's just such a fun calculator. So let's go back to our scientific calculator, and we'll just work through the steps. It is being recorded, this session, as we speak. So I will send you a link maybe Friday, maybe Monday, with a link to this video so you can rewatch it if you get stuck or you missed something. But you're welcome to just pop a question into the chat if you need any help with anything or I'm going too fast. Okay, so turn your calculator on the on button. Your second function button is this orange button here, and that just activates any of your orange functions, most of which we won't use in intermediate phase. Okay. But it is also used to switch off the calculator. The calculator will switch off automatically after 15 minutes. And if you switch it back on, it will have whatever your previous calculation on the screen was. So that's really nice for those kids who get very distracted or have to watch the end of Frozen right now. Sorry, Frozen is the thing we're currently watching in our house. Okay, great. Hi, Michael. No, we've just started, so you're not too far behind. Then this alpha key here is just activates your blue functions. So your statistics, your memory buttons, that sort of stuff. BS is for backspace, deletes something that you've typed in. And then change will change the way your answers look. And we'll look at that when we look at fractions just now. And then, of course, equals finds your answer. Okay, great. So on your calculator, you have 4 different modes: normal, stat, table, and drill. So normal does things like fractions, integers. It's got a shortcut for prime factorization, which I will show you for the grade 6. Your stat, I don't know if I've actually included stat in here, but if you want, I can show you how to use the stats function. So for your own class marks. I mean, I wouldn't use it in class with your grade 6s, and because we'll just be teaching them shortcuts way before they're supposed to know them. But I can show it for you for your own marks in class, because you do have space for up to 100 marks. So you can use it for filling in your caps, documents, etc., etc. Then your table mode, we're definitely going to play with today. We're going to look at finding factor pairs and multiples of a number and doing patterns and functions. And then, of course, the drill function, which we're going to move on to next. So we've already discussed the S25. So the first thing before we do drill is the shortcut for your class marks. So I'm going to go to my calculator now. And the nice thing about this is it works on any sharp calculator. So you can use this function and you can show it to your fellow teachers. It's not a complicated or difficult one to use. Okay, so firstly, we use our fraction button. And let's say, for example, we've set a test which is out of 70. So it's more like an exam. So we've set an exam which is out of 70, and we want to convert our exam marks to percentages, so a total out of 100. So at the top, we put whatever we want to convert to. And at the bottom of our fraction, we put whatever we are converting from. Now, I know this feels weird, but just trust me. We've just tweaked the formula a little bit. Okay. Then we're going to say times, and our first student gets 40 out of 70. And we say equals, and he gets 57 1/7, or 57,14, so 57% if we round it off. Now your next student gets 55 out of 70. So instead of typing in this formula, all we're going to do is press the mark in and say equals, and that gives us 78,57, or 79%. And the next student gets 23 and equals, and so that student gets 32,85, or 33% if we round off. And you can just keep typing in mark equals until you're done with your class list. So it really is a nice, easy way to do it. If you are doing it on a basic calculator like the S25, what you would do is say 100, or where you're going to, that becomes divided by where you are coming from, so the total your test is out of. This is an equals, times, and your first student's mark equals, and then just mark equals, mark equals, mark equals. So same concept with the constant function, but just slightly different steps. Okay, cool. So let's talk drill, because drill is just so much fun, and it's a critical skill that we need our students to have. And we can't do that thing anymore where we make them stand and we smack their hands if they don't know the answers, because that's not allowed anymore. So now what we have to do is find other fun ways to get them to learn their mental maths. And there's amazing research on this that shows that students who can do mental maths in primary school, who have strong mental maths, so in other words, they have accurate answers and they are able to answer quickly. So accuracy and fluency, those are the 2 key concepts for mental maths. Those students get better results in matric. So there's actually a direct correlation between your strength in mental maths and your final results for maths, which is a pretty exciting thing if you think about it. So it's something that we really should be pushing our students to do. Okay, so let's start with math. So all I've done here is I've said mode, and then I've chosen 3 for table. Okay, and then here on my 0, I'm just going to say 0. Now you have an option. You have 25 or 50 or 100 questions. You can go in either direction using your arrow keys up and down. And on this left and right arrow key, you can choose the type of questions you want to do. So plus questions are 0 to 20 plus 0 to 20. Minus questions are the opposite of plus question. So it'll be 40 minus up to 20. Okay. Times is 0 to 12 times 0 to 12. Divide is the opposite, obviously without dividing by 0, because 0 is undefined and you cannot type undefined into the calculator. And mixed questions are really nice for your grade 6s and 7s. Now, the S25 has the same functionality. It looks slightly different. Unfortunately, I don't have a simulator for it. But it's got exactly the same functionality. So if you give me a sec, let's just go back to the picture of that S25 and I'll show you. Here it is. So on the Q button, so to start the questions or to start the mental maths function, you're just going to press the Q button. You're going to say choose 25, 50, or 100. You can see there's the 25 at the top there. Then this button next to it, the plus, minus, times, divide, that allows you to choose what type of questions, and exactly the same parameters as the ones I've just discussed in the other calculator. So plus, minus, times, divide, or all 4 of them together. And then when you want to start, you just press equals. So on both of them, you would just press equals. So what happens is the calculator is going to ask you a maths question. You then need to type in the answer. So 31, right? 31. And we say equals, and we get a tick, and we get a new question. Okay. If we get the question wrong, it's going to mark it wrong, and it's going to repeat the question again for us. And because it's very patient, it's going to keep asking until they get the question right. Okay. Now, obviously, there's no point in them trying 40 times to figure out the question, because then they really don't know the answer. And are they really trying? So what you can do is also ask the calculator what the answer is. So you leave the space blank and you press equals, and it will show you that the answer is 4. So 16 minus 12 is 4, and then it gives me a new question. You can see I don't get a mark for that, for asking the calculator what the answer is. Then I get a new question, and I can type in the answer again. So let me just do a few here so I don't have a dismal mark. Once I'm done, all right, I'm just going to skip the rest so we can go through. You can see this is the mixed question. It's completely random. So every time you start a new set of questions, it's a new set of questions. It will always be completely random, never in the same order. So it's really just a nice practice function, particularly when you're warming up students or you want to explain one concept to a single student. You can have the rest of them doing mental maths on the calculator. Right, now I've just skipped all the questions, so I'm not going to get any marks for those. When I get to the end, it says press enter, and I say equals. And so I got 4 out of 25, which is 16%. So here you can actually track how well they're doing and see whether or not they're improving. Now, we did some research a couple of years ago with this calculator, and we just had such great results with the students. They really improved their results. The fluency and accuracy increased. So it was really quite exciting to see that. And students who are using, these tally marks to do multiplication or division, we're actually not using that so much. And it really, that alone speeds up their time quite quickly. So it was really quite exciting to see. So that's the mental maths function. Are we all happy and good? If you're good, just wave your hand at me. If you want me to repeat that, you can just ask a question in the chat. Awesome. The other thing I want to show you on the drill function is your table. Now, if we go 3 for drill and then choose 1 for table, what table actually allows us to do is our counting in practice. So on the S25, you only have serial, which means in order. So in other words, if I choose 4, my answers are going to be 4, 8, 12, 16, and so on. On the 535, you actually have the 2 options. So you have serial, which is like that S25, or you have random, which mixes up the multiplication question. So it's just a more advanced version. So let's pick 6. We'll do it randomly. Actually, let me do it serial so you can see. So what's going to happen is, you see, 6 times 1 is 6, and 6 times 2 is 12. So all they're asking us to do is actually count in 6. And it goes up to 12. I have done this wrong. 24, and so on and so forth until you get to end. And again, it will count your marks for you and give you a percentage. If I did it randomly, You'll see now it mixes up the math. Oh, that's ironic. It mixes up the questions for you. So they actually have to know what the multiplication answer is. And this is particularly nice if you have a student who is struggling with a particular times table, like the 7 times table and the 9 times table. Those ones that just don't have a pattern, particularly the 7 times table. So those are the different mental maths functions you can do using your sharp calculator. Cool. Everyone happy so far? Great. So the next thing that I want to show you, I actually want to change the way this is displayed. Okay. So what I want to do now is I'm going to go home. Home is just a shortcut. And we want to talk about mental maths. Okay. So on your mental math, sorry, I don't want to talk about mental maths. I want to talk about line division. Let's say, for example, you have a division sum that says 152 divided by 7. So let me just find a space here. So we have 152, okay, and it's divided by 7. Now, traditionally, we would say 7 goes into 1 times, so I put my dot there. 7 goes into 15. So I count in 7, so it's 7 and then it's 14. So there we go. So 7 goes into 15 and then it's 21. So it's number 2. So it's 2 times. 2 times 7 is 14. So there's my 14. I subtract 1, bring down my 12 and my 2. So now I've got 12. 7 goes into 12. Well, it's 14 is too big, so it's only once. 1 times 7 is 7. I subtract, and that gives me 5. So my remainder is 5. Okay. Now that's great if you have a basic one like I've given here. What I want to show you now is a way to do that with your calculator. So on your calculator, we're going to start off in the same place, but it's for those students who can't do this here, right? And this is, I used a simple example of 7, but it's actually better for multiples with higher numbers. So like, for example, if we had 17. In fact, we can change it. Let's make it 17. So I'm going to change this to 352. Okay. So 17 goes into 35. I hope I've calculated this right. Okay. So we're going to do on the calculator, we're just going to take 35. All right. And we're going to say, we're going to use a special division key. So if I used my regular division key, and I said 35 divided by 17, I'd get 2 and 1/17. So you can actually see there's your whole number, there's your quotient, and there's your remainder. But we can also do it using a special division key over here, which is called int divide. And what that does is it gives us the quotient and the remainder, which is 1. So same. It's just okay. So, oopsie. You see, whenever I use my calculator, I lose what I've written down. I don't know why. So we said 352, right? And it was 17. So we saw that it was 2 here and a remainder 1. So now we're going to say 17 goes into 12. Well, actually 0 times. And my remainder is 12. And I'm done. So that's just a nice way to do integer division without, you know, with students who really struggle, particularly with higher values. Okay. Any questions on that one? We're all good. Fantastic. Awesome. All right. Let's do finding multiples. Now, this is just so much fun. So on the calculator, we're going to use our tables. We're going to say mode and to the table. And what we're going to do is, let's say we're looking for, I'm just going to use a very basic example of 7. So I want multiples of 7. So I'm going to say 7, and I'm going to put an x next to it. Okay, and that just means 7 times x, and I'm going to say equals. Let's not complicate things. So I'm just going to leave function to alone, leave my start and step as 0 and 1. So again, equals and equals. And here are all my multiples. So 1 times 7 is 7. 2 times 7 is 14. 3 times 7 is 21. 4 times 7 is 28. And so on and so forth. Now, it's great to actually show the kids where your your multiplication table, because that's basically what this is. But what's really nice is your table is unlimited. So you can ask them, okay, guys, what is 30 times 7? And they've just got to run quickly down the table and look for where 30 times 7. Ah, thank you, Michael. I'm glad you like that function. And again, what's 55 times 7? So we just scroll and we look for 55 times 7. Now, if you aren't going to join us this afternoon for integers, and you are a senior phase teacher as well, so don't panic if you're just in senior phase. But what's really nice is even though we started at 0, you can go back up into the negatives. So 7 times -1 is -7, and that's where this comes from here. So they've got the negative side as well. And it's just a really nice way to show them what happens with your multiples and that they go in both directions. Okay, and this is a good way of leading into functions. It's getting them comfortable with patterns and so on. Now, what we can also do is find the factor pairs using our table mode. So let's say, for example, we want factor pairs of 36, because that's my favorite example. What we're going to do is we're just going to press the fraction button. And again, we're going to put it over an x. Okay, so it's just 36 divided by x, which is any number that we substitute in. Again, ignore function 2, step and start at 0 and 1. And here are all the factor pairs. So, sorry, before I continue, anything divided by 0 is undefined. And this stripy line is very important later when they get to grade 10 and we learn that it's an asymptote and they start drawing graphs with asymptotes. But in grade 6 and 5, all they need to know is when they see this little line over here, it means undefined. It means I can't do it. It means nuclear bombs and blah, 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 water holes and etc. etc. Okay, so it's just something that needs to be reiterated with them. I often meet students who should be learning this now at this age at grade 10 who don't understand what undefined is. Okay, so it's just an important thing that they know, especially for going into maths later on. So you've got your factor pairs, 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5 and 7.2. So here we can see, because it is a decimal, we know that 5 is not a factor and we can ignore it. And 6 and 6, and then we've got 7 and 5, whatever. So we know that we've actually gone back because now we've got values repeating themselves. They've switched sides, so we know we've got all the factor pairs. And this works well with any value. So I can put in here, say, for example, 48, and go and look for the factors. So now I've got 1 and 48, 2 and 24, 3 and 16, 4 and 12, 5 and 9.6. So again, 5 is not a factor. 6 and 8, 7 is not a factor. 8 and 6, okay, I've got all my factor pairs. I can continue. So this is just a really nice way to check. And it's a nice way for them to learn how to look for factor pairs. So I need to say, what is 48 divided by 1? It's 48. So that's a factor pair. 2 goes into 48 24 times. Yes, that's a factor pair. So it's just a nice way to teach them and show them how to check that they've actually got all of their factor pairs on the calculator. Any questions on this section? We all good? Haven't put you to sleep yet. Your coffee is not cold and bland. I think mine is. So prime factors. Here we go. So we're going to go back home. Awesome. Thanks, guys. So prime factors, we only start learning in grade 6, right? And we teach them this methodology with the ladder and the tree. So the ladder is, if I have 16 and then I say 2 goes into 16 8 times, and 2 goes into 8 4 times, and 2 goes into 4 2 times, and 2 goes into 2 once. And I have 4 2s, 1 2 3 4. So I have 2 to the power of 4. Okay, and the tree method, similar, we just break up 16. So we have 16, which is 8 times 2, and 8 is 4 times 2, and 4 is 2 times 2, and we count 1, 2, 3, 4. So again, 2 to the 4. Both methods work, and I've just used a basic example here with the 16. But because we're going to be spending a lot of time offline or online with our students, we need to give them methodology for checking their own work. And so this function is just very nice and it gives them a nice introduction to exponents as well. So if I say 16 and equals, and then I press second function and p fact, it gives me 2 to the 4, which means 2 times 2 times 2 times 2. So if we did something else like 87, so 87 equals second function p fact gives me 3 times 29. So again, it's just a nice way just to check the answers and make sure that they're on the right track as well. Cool. Now let's look at fractions. So we know that fractions are not always everyone's happy place, and that's fine. So let's say we want to add 4/5 and 2/9. Okay, so we have 4 over 5. So you can do it that way. Or you can say, press the fraction button first and then type in your fraction values. And then we say equals, and that gives us 1 over 1 and 1 over 45. And if I change it, it now gives me my improper fraction. And if I change it again, it gives me my decimal. So this is a nice way as well to check if I've got the correct changes between the 3 different values. So here I can say it's 5 over 8 or it's 0.625. This is more appropriate to grade 7 work. But you know, it's always nice, but you do have to do improper. So we could say 2 plus a half, which will give me 2.5. And here is my improper fraction. Now, if you wanted to type an improper a mixed number fraction indirectly, you can first say the whole number, then press second function and your fraction button, and that just glues your fraction onto your whole number. And we can type that in. Or we could press the fraction button first and then press the back arrow, type in our whole number, and then go back and type in our fraction as well. And there we go. And again, you can change it so that it works for the answer that you're looking for. Great. Okay, so that's fractions. I didn't actually see anything on recurring decimals. I actually think it's later. Do you want me to do the recurring decimal function with you guys? If you do, just wave your hands at me and I'll do it. Otherwise, I'll just skip through this section. But you will get access to these slides. So, okay, Sam says, yes, please. Oh, great. I see lots. Okay, cool. Let me show you recurring. Yay! So this is a cool new thing that we've added. Awesome. Thanks, guys. Which is the recurring decimal function. So firstly, you actually need to turn it on. So we're going to go press setup, and we're going to choose 5 for recurring decimal, and then we're just going to press 1 for on. Now let's say, for example, we have 87 divided by 7. That should give us recurring decimal, right? And we say equals, and that gives us our fraction. And if we change it, there's our improper. And if we change it again, there's our recurring decimal. And if we change it again, there's our full. So you can see there's where the repeat is 4 and 4. And then, of course, this has been rounded off. So it will give you up to 9 significant digits. Okay, that's for your recurring. And it's really nice because you can also put in, for example, a recurring number. So the rule of thumb is just to do it past your screen and then say equals. And that does not make sense. There you go, 2 over 9. So you can put in a decimal and it will give you back the fraction format as well. And you can even do repeating values. So you just do it a couple of times as well. There we go. And there's, again, your recurring decimal fraction. So it's just a really nice way just to check answers again. Remember, the calculator in grade 6 is more for checking answers and for teaching concepts than for actually doing the work on the calculator, because we still want them to gain those skills. So the next thing that I want to show you, which is really nice, is the patterns that you can do, because we have a constant function, and you can do this on the S25 as well. You can create a pattern on your calculator and you can just work through that pattern. So let's say we start off with 3 and we want to keep adding 5 every time. So we say 3 plus 5 is equal to, and then we just say plus 5 is equal to, and then we just say equals, 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 and there we can see our pattern going on. Okay, and they can go back up and count. So we can say there's 1, there's 2, there's 3, there's 4. Well, actually, there's 1, here's 2, there's 3, there's 4, there's 5, there's 6, and so on. So you can get your term patterns, and they can go and look what the pattern is. And of course, you can do this with multiples as well. So we can say, okay, I started with 3, and I'm going to keep timesing by 2. So I have 3, there's 1, there's 2, there's 3, there's 4, there's 5, there's 6, and so on. And so you can show them the multiplication. And you can see how much faster this one is growing compared to the previous pattern that we did. So that's also a really nice way to do patterns with them. And both on the S25 as well, it works exactly the same way. So the other thing that you can do before I share this, let's just look here at this example. So let's say we give them a number sentence, and it's 10 times a block plus 2, and then you can substitute into the block. So what we could do on the calculator is go into our table mode and type this pattern number sentence in. So instead of using a block, we use an X plus 2. Okay. So there we go. So we're starting with 2 and we're adding 10 every time. That's basically what the pattern is saying. And we're just going to jump through all of these. In grade 4, 5, 6, you don't actually need to change any of those. And here we go. So here's my first pattern is 12. My next one is 22. And I'm adding 10 every time. And they can actually see that from the pattern. So here's your input value, and your answer would be your output value. And you can create any function as long as it's just got one X, or well, lots of X's, but just a single variable in that space. All right, great. So the last thing that I want to share with you today is probability. And so we're going to go back home. Now, on your calculator, you actually have a very nice random function. So this first random does random decimal places between 0 and 1, not something we really use between grade 4 and 6. But your dice does random values between 1 and 6. So you can create tally tables with your dice function. You've got a coin, which does zeros and ones because it's math coins. So you can tell them 0 means heads and 1 means tails, and there are heads and tails. And then, of course, your lottery or your random integer, which just generates numbers between any two values. So if, for example, I wanted to play the lottery with, in fact, let's do that. So what I'd like you to do is in your chat function, don't worry, I won't steal your lottery numbers. Type in your 6 lottery numbers between 1 and 52. Okay, so I'll give you a minute to do that. I'll sip some coffee. My coffee's cold. So type in your lottery numbers, just 6 values between 1 and 6. Oh, sorry, 6 values between 1 and 52. Let me not confuse the issue. So your balls in the lottery are 1 and up to 52. And then you have 6 possible options. Okay, I see someone's put their lottery numbers in. Ah, there we go. Yay. Okay, Tanya and Rish and Elizabeth and Sher. Okay, great. So if you're doing this on Zoom, it's really nice because they can't go back and change what they've now put in. So there's no cheating in this method. If you are, however, doing this in the classroom, what I would do is get your students to write their numbers on a piece of paper and switch their piece of paper with someone sitting next to them. I see another one coming through. Thanks, Chantal. Okay, so what we do, I'm just going to repeat this so you can follow all the steps. So it's second function and 7, and then we press 3 for random integer, and then we can say 1, and this magic button over here just is a comma. It tells me 1, 2, and then I put in 52. And let me see, I've got one more number in here. Thanks, Sam. Okay, are you guys ready? So check if you've got your lottery numbers. So I'm going to generate 6 random numbers. The first one is 12. Let me write it here so we can all see. So there's 12. Then the next one is 44. So we'll write it down. And then the next one is 15. Sorry, let me just make giant slashes here because I'm writing terribly badly. And then the next one is 10. Wow, these are very low numbers today. Yesterday it was all high. And then the next one, there we go, is 48. And the last one is 24. So did anyone get 12? You can just raise your hand if you did. Nobody, okay. Did anyone get 44? Okay. Did anyone get 15? Oh dear. Oh, there we go. Okay. Some people got 15. Okay. Did anyone get 10? Okay, great, great, great. Did anyone get 48? Awesome. And did anyone get 24? Hey, now if you got all 4 of those, you would have actually won some money. That's pretty exciting. I'm sorry, you're already going to win a calculator from me today, which I hope you feel is wonderful. Oh, sorry. So hopefully that's something cool for you. All right, let's go back. So some nice ideas that you can do with your functions is create those tally tables. So everyone who's got the calculator now, if you're doing Zoom, all of your students can download the simulator onto their laptops because it's free. It's a great resource to have, and they can all generate a random dice number or a random integer between 1 and 10 or whatever you like, and you can actually do tally tables like that. You can create a poll on Zoom, so we can I think polls are in webinars, so I'm not sure if they're in meetings. That's just something. You can play snaps, so put your students into breakaway rooms and get them both to generate a random number between 1 and 50 and see if they both get the same number, which is exactly like it would be if you were playing with cards because your probability is the same. Multiples, so you can generate random numbers between, because I think for multiples you need to know 2 decimal or 2 digits, so you could put between 1 and 100 and then get them to write down the multiples of the random number that they generate, or 5. So there's really so many nice ways to use this functionality. And then of course the lottery. I also like to play a game with the students. So what I do is I ask them to choose a number between 1 and 6, and then I roll the dice on the calculator. And then what they have to do is show me their, sorry, I've explained this terribly well. Okay, let me start again. What I do is I ask them to choose a number between 1 and 6, and they need to then show me that number. So if you're doing it on Zoom, you can have them put it into the chat function. If you're doing it in the class, I would just get them to raise their hands with the number that they picked. This prevents cheating. And trust me, I've seen it a lot. And then what you do is roll your dice on your calculator, and then if they got the number on the dice, they can stay standing. If they didn't, they have to sit down, and then you do another round with them. And it can get quite boisterous, which is quite exciting. It's such a fun game to play with students. And then of course you can do the coin, which is just 0 and 1. So they may choose either 0 or 1. And obviously this takes longer. And then you can discuss why it takes so much longer with the coin versus why it takes longer with the dice. And the reason is because the chances of you choosing the right coin value is 1 out of 2. So it's a half. Whereas the chance of choosing the right dice number is 1 out of 6. So it's a much smaller probability. And this again goes back to your fractions. So which fraction is bigger? The half is bigger than a sixth. And so that's why we need to have a good foundation in fractions, because it applies to so many other things as well. All right.